In last video, you have learned about the motion, force and work. Now, we will take a revision about it. See that you have learned about the distance. Distance is the length of the route actually transferred by a moving body in respect of the direction. Is called as distance, and distance is the scalar quantity. You have also learned about the minimum distance traveled by a moving body in one direction from its original point to reach the final point is called as displacement. You have also learned about the velocity, and today we are going to see about the average velocity and instantaneous velocity. So let us see about the average velocity. The velocity of an object can change even while it is moving along a straight line. Now see that this truck is moving, its velocity may be changed even though it is moving in a straight line. Suppose that a truck is covering a distance of 440 km from A to D. See, it is A point. From A point to D point, it is covering how many? 20 plus 10 plus 10, 40 km from A to D in a straight line. That is, its displacement will be a 40 km. Displacement means what? Whatever it moves from A to D, a distance covered by it, it is a displacement of it. If it requires altogether 1 hour for this, its average velocity will be 40 km per hour. However, if the truck transfers a 10 km distance AB in 10 minutes, see that here it is given AB. So AB a 10 km, to travels a 10 km it takes 10 minutes. Similarly BC, from B point to C point it takes 20 minutes, and from C to D it takes about 30 minutes. Then velocity from the distance AB in kilometer per hour. Now see, 10 kilometer it takes 10 minutes, so it is 10 minutes. That is 10 kilo 60 kilometer. If you multiply by 6 to this, it will be the 60 minutes. So 60 kilometer per hour it will take. Now next, now reduce the velocity from the distance BC and CD. We see that the velocity of the truck is different in different segments of the road AB, BC and CD. However, the average velocity of entire route AD is 40 km per hour. The velocity at a particular moment of time is called as instantaneous velocity. The instantaneous velocity can be different at different place. So we see that its velocity will be the different at different place. Now let us see about the acceleration. In the previous example, the trucks covers the distance AB at the velocity of 60 km per hour, which you have already seen here. 60 km per hour. So it is also given here, that is 60 km per hour. BC at 30 km per hour and CD at 40 km per hour. It means that the velocity of the distance CD is greater than the velocity of the distance BC. See here that it means that the velocity from the distance CD is greater than the velocity of distance BC. See, CD, how much you have here? CD is 40 km per hour, whereas BC is 30 km per hour. You will see here. Now that is here, see that here you have a 30 km per hour. and here you have a 40 kilometer per hour. So the distance is the, greater there from the number of the second required for the change in the velocity to take place. The change in velocity per second can be deduced. This is called as acceleration. So whatever this is called as a acceleration. When we will see about definition of acceleration, we will come to know about it. What is acceleration? Now let us see about the acceleration, that is acceleration is change in velocity upon time taken. Whatever time taken, that is change in velocity upon time taken for the change. Now we will see the next part of it. You know that the truck's driver increase or decrease the velocity of the truck by the means of the accelerators. See, whenever truck is moving, bus is moving, a four-wheeler, whichever is moving, a driver, what he do? He uses accelerator to increase or decrease the velocity of his vehicle. You might have seen a toy car that's run on the clockwork spring. When it is released on the flat floor after winding up the spring, it goes in the straight line. However, when it is hit on one side, it change direction and keep going. If it collide into the wall, it stops. It means that its velocity changes. See that a small kid is playing with his toys. What he do? He will give a spring, wind up the spring. When he will wind up the spring and release that, whatever his toy, it will move in the straight line. But if it hit on one side, it changes its direction and keep going. If it collide into the wall, it stop. If it is collide means what? It will go on the wall and there will be some obstacle where it stop. It means that its velocity change. How did this change takes place? It happened because the car come into the contact with something external to it. On a football ground, how do the direction of the ball move in a straight line? Changes. See that in the football ground, if one player hit, other will come and hit it. We see that some player changes its direction while kicking it. When its direction changes, the velocity of the ball changes. That is to say that an acceleration takes place. The interaction that brings about the acceleration is called force. See that interaction that bring about the acceleration is called force, and force act on the body. Indirectly we see that force is acting on the body. Now we will see use your brain power. The unit of acceleration is meter per second square. Verify this. Now let us study the relation between force and acceleration. Take a, take a glass marble and let it roll on a big smooth tabletop. After some time its velocity will decrease and it will stop, which you have already seen. There will be a marble here. If it is rolling, it will be rolled on the table and after time it will be stopped there. On a carom board too, the carom coin push up a striker will move forward some distance and then come to the stop. If a coin is pushed after applying talcum powder to the carom board, it will keep moving for a long time and then come to the stop. See that here you will see a carom board. Here is tractor. When you hit it, if you apply a powder to it, your surface will become smooth. When you hit, it will also go here and here. What can we infer from this? The velocity of the coin decreases due to the force of friction and the coin stops. If the friction between the carom board and the coin is reduced, the coin keeps moving for a long time. It could mean that if no force of friction is attracting on the moving body, it will keep on moving with the constant velocity. So this it means that if no force of friction is acting on a moving body, it will keep on moving with the constant velocity. If you apply a certain force to it, what will happen? It will move neither in highway or high speed will be increased. If after a few times its speed will be decreased. So in this way we have seen about the relationship between force and the acceleration. The scientist Sir Isaac Newton was the first to study force and the resulting acceleration. In next video we will see about the first laws of Newton. Until then, thank you.